Hi everyone, welcome back. So far, we have seen how you can build a pipeline using the Trel automation platform, and we have built a customer lifetime value prediction pipeline using Trel. In this video, we are going to take a look at how do we manage data quality using Trel, what facilities does Trel offer for this. We will also look at some experimentation related capabilities of Trel. All right. So Trell offers data quality tests by integrating with Sodacore. So the tests that you write are actually Sodacore rules. It's called SodaCL, and it has some uh, high quality functionality, high quality capabilities, such as uh, condition on the various columns, all kinds of rules. You can go into details of documentation of SodaCL to learn more. What Trell does in this picture is that it applies the data quality unit test to each data set that is being generated through Trell, and it lets you see the detailed warnings at various points in the UI. So far, we have seen this already when we look at the notebook. And we know that at the end of the notebook, we have a validate function, and that is responsible for pulling the data quality or using the data quality rules that are given to it by the Trell platform, applying it and producing results. And the helper function also makes the results available to the Trell platform. Now, the Trell platform will pick it up and we will see some detailed results. You can see the details of it. And if you have data quality warnings, we will see alerts. If you have data quality failures, we'll see the halting of the pipeline. So this is something that we want to take a look at next. So let's briefly take a look at the data quality rules themselves. We have seen this briefly already, but let's just quickly revise. So we have in the version schema information of clv.features. In version 1, we have some schema, but below we have the Sodacore rules. Let's just focus on this one, which says the total purchase value um, should be if it is more than 10,000, make a warning, and if it is more than $100,000, there will be some problem because we don't really expect this to happen ever. So that's a sanity check on this data, and this is something that in the demo we are going to be uh, using to test our failure cases. Okay, so um, uh, we are going to do a demo where we're going to cause a problem in the pipeline by some data quality problems in the pipeline. All right, let's go ahead. So we will add two data sets. Specifically, if you look at the sensors, we have 9.6 and 9.6. We only have 9.4 of transaction history. We're going to add 9.5 and 9.6 of transaction history, and they have data quality problems. So these are the commands, the command line version of the add dataset UI. So dataset add transaction history, and then you have the date demo, and the 5 is going to generate a warning, 6 is going to generate a failure. And as soon as we add this, we can see that the sensor has oh, actually the sensor wouldn't pick it up because sensor is looking for the path, but we have explicitly added to the catalog, so the jobs would have picked them up, yes. And it is running 9.5 and 9.6, and what we're going to see is let's just take a look at what happens. Coming back, we can see that some runs have succeeded. So let's take a look at the tasks table to see what has actually been completed. So what we find is that the CLV features for 9.6 has failed. CLV features for 9.5 has succeeded, and so it was able to run the model and predictions for 9.5. So let's take a look at our incidents. Like, did we get any incidents from this? And what we see is that um, we have a number of validation warnings. These are mostly related to model metrics, and we will take a look at that very soon. But the ones that we really care about is the ones from clv.features. So what we see is that the clv.features has a validation warning for 9.5, and for 9.6 there is a failure and there is a validation fail warning for 9.6 as well. So if you take a look at the one for 9.5, we see is that what we see is um, the R2 value of, excuse me, so I'm actually looking at the wrong one. This is again model metrics. We should be looking at clv.features for 9.5. So let me just, so this is from the pipeline of 9.5. So I'm just going to clean this up a little bit. So you can ignore, 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 and ignore. And this will keep, so we'll take a look at it from here. So let's see, let's take a look at the logs. So what we find is that the total purchase value is exceeding 10,000. So there is some questionable number over there. And when we look at this one, we see that the total purchase value is actually exceeding 400,000. And that's a real problem because our upper limit is 100,000. So, and this is the reason why clv.features, there's a failure and we have a task failed notification for that job as well. Now that we have these incidents, our main concern is how do we actually resolve this issue? So we are not going to resolve 9.5 and we're just going to ignore that. It's a warning. So I'm just going to hit ignore and we're going to do something about the 9.6 and resolve it. So we actually have um, the replacement data for 9.6 that we can use. So let's take a look at how we can how this will be fixed. Yes, so we're going to replace this failed dataset clv features 9.6 demo s3us east2 with this path. So we go back here, we've done this once before. You can see transaction history, the date has to be 9.6 this time, label is still demo s3us east2, and then we're going to paste this over here, make sure it's the fix. Okay, we're going to save that. And now we have, if we come to transaction history, we have this 9.6 has two different versions. We are on version 2. You can't see the previous one which is there because it's been suppressed by the new one that we entered. If you want to see both of them, you can come to this one and see show all versions, and then you can see both of them, and you can see that the old one was the fail one and the new one is the fix that we have essentially. Okay, so we come back here and we want to rerun the task to fix it. So we come here, we execute this again and we click submit, and now this job is running. And while it is running, it's important to note that because 9.6 failed, we did not actually run model and predictions for 9.6. So the pipeline for 9.6 is halted at features. You can't proceed beyond it. And it's clear now why this is happening is because the formulas no longer line up. There is the prerequisite for model set 9.6 does not complete. It's not being met right now. The requirements for the formula is not being met. So as soon as this finishes and the data set is created, the formula is being met and will be met, and CLV model 496 will proceed normally. Okay, so it just finished. So if we refresh, we can see that the model is getting picked up and then the feature will get picked up as well. Okay, so well, let's come back here. And next, so we have covered this. Let's take a look at the data quality versioning. Okay, so instead of data quality versioning, we will just do schema migration because schema and data quality are kind of merged together into one mechanism. So we'll take a look at it that way. But before we get to that, actually belongs to the next slide. Before we get to that, we can just quickly go over these points. um, there are other data quality activities that are typically involved in data science. Some of it is interactive data profiling and deep dives and anomaly detection. These are not directly under the scope of Trel. These are under the scope of the business logic that you will be automating using Trel. And as long as you write the business logic, Trel can take care of that. We are planning to add one-click data profiling capabilities to Trell. So a predefined data processing job that you can use, that you can pre-register, and you can directly use that to um, do data profiling of your data sets. Data cleansing and imputation is another activity that you often need to do when you're doing data science. And this, um, as part of the Trell toolchain, you're supposed to use SQL for this purpose. And we are also planning to add LLM prompts for generating the cleansing SQL based on the data profiling results. Drift detection is another functionality that you typically need in data science. So, uh, tools like SageMaker offer drift computation. So, if you bring the drift down to a number, then you can treat it as a normal data quality metric and take full advantage of the alerting and the halting when it comes to that metric using Trell. So, next, let's take a look at experiment tracking and reproducibility. So, when it comes to experiment tracking, one of the requirement is feature store management, right? You have a feature store and you want to improve the feature store with new features, right? And if you're going to improve them with new features, you want to figure out if they actually are working better. So you want to have your original set of features and a new set of features, and you want to kind of figure out if it is really making a tangible improvements when you actually adopt the new set of features. So this is the demo we'll be going through now. All right. So we add what we're going to do is we're going to add all four data sets for 9.7, and from 9.7 onwards, transaction history and new customer data gets a new column, max purchase value. So this is captured in schema 2. So the script is going to add schema 2 for transaction history and new customer data, and the new data sets are going to be under schema 2. So let's just verify that that is what has happened. Right. So the sensors have picked up the new data sets that we have placed because they are all in the expected locations. So we can see that transaction history is 2, new customer data is 2, and this did not require us to make any change to the sensor or any code. None of that is required. We simply changed the default schema in the classes, and that should reflect the data that is provided. Okay, so now that we have new columns in, and we can just quickly briefly confirm that this contains the new column. So new customer data, we have uh, version 1 is like this, and version 2 has this max purchase value. I think previously the version 1 didn't have the all the columns there, but this one has all the columns that it actually has, and it has max purchase value. Okay, so let's take a look at the next step. So we are going to create a new feature store schema, clv feature store schema, which contains this value, this column max purchase value. So we're going to show the schema. I'm going to go ahead and edit this, make a copy, and we're going to add a schema. So you have two true content, and right here we'll copy this column and paste it here, and we'll say max purchase value. Okay. Um, oh, we will not make this default for now. So we're just adding a new schema for experimentation. It's not our default right now. Okay, so we'll continue. So now what we're going to do is we are also going to do something similar for model. We have added a new schema for clv.model as well to reflect that this is going to have a new feature in its model. And now we will do our A/B test. Okay, so we need to essentially create new jobs that are actually capable of taking advantage of this new schema that we have, uh, max purchase value, uh, new column that we have. So let's take a look at the new notebook that we have prepared, which we cloned the data preparation, model creation, and prediction generation notebooks in this folder, and we have gone ahead and made a few changes to support it. So it's very interesting to see how this actually supported. So here, this is a new line where we are pulling out the schema version from the output entry, because in clv.features, the output is the one which is going to be having a new version. So we pull it out, and some of the code will be different based on the version. So if the output schema version is 2, then we have this new column that we can use. So we have a string which has that column name, and we're going to put that string in the middle of our SQL. So this SQL now has a new column if we are in version 2 of the output. And yeah, actually that's pretty much it. We are going to go ahead and save it. When it comes to model creation, we will have a little extra effort. We have, let's see. So the schema version is now a matter of input. So clv.features has input schema version 2, and if input schema version is 2, we have in our minor feature engineering section, basically a log scale, log features. We have extra lines, and furthermore, here we will add this to our feature column. Now we have 1, 2, 3, 4, 5 features instead of 4. We build a model, and when we come down here, we get our predictions and scoring. And when we come down here, yeah, no change. It's all the same code because we have built that model with the new features, and we're going to just compute the metrics just like before. So largely, the change is just getting a new column, computing a new column, and using the new column to build the model. Okay, so now that we've seen this, what we're going to do is clone the clv dot features job to create the clv.features MPV job, which is going to use the new notebook that we have. And this notebook is going to have output schema set to 2, and then the label is going to be set to clv features.mpv. So let's take a look at how that works. So we go here, we're going to essentially clv.features. We're going to say modify registration. So one thing you can do in Trel is when you say modify registration, if you change the name and you save it, it becomes a new job. It becomes a new registration actually. So that is the convenience that we are going to adopt. Make this change, and then so the inputs are fine. here we say um, schema version is 2 and clv, sorry, label is clv features mpv. Okay, so here's we are a little more fine-grained control over the formula. So the inputs of the formula is the same as clv features, but the output formula is now a little different. We are changing one of the columns of the output to clv features mpv. Okay, so this is a new job. It's not version 2, it's a version 1 of a new job. Okay, so we're going to do the same for uh, clv.model. So you go to details, modify registration, you go for mpv, and here we are actually going to change the label here entirely because the formula changes in both the inputs and outputs. So you can just set it here, so change it into the inputs, and the outputs will inherit that directly. And here we will set schema version to 2, and model metrics remains version 1 because we're not changing the columns in model metrics. Okay, so uh, new features. Okay, so if we go ahead and whatever jobs, okay, we can now go ahead and enable the scheduler and trigger the scheduler, and that should create a task. Okay, so I made a small mistake in my registration. I did not put a lower limit of scheduled start timestamp of 9/7. So it went ahead and processed it for all dates that we have. So this is going to take more time that we need, that we have. So I'm just going to go ahead and select these things and say cancel all these tasks. Oh, it is, some of them are already failed. Okay. Um, Okay, so what we see is that some of them have failed, and let's take a look at what actually happened. Um, just a bit of a segue in our demo. So these are the failed ones, and the ones that have canceled has got canceled as well. So if you take a look at this, it should actually be quite obvious why these failed, because there simply isn't a max purchase value um, in the table. So that is a reason why it basically couldn't process it. Okay, so the important thing is CLV features MPP actually is successful, and if we go ahead and trigger model MPP and enable scheduler and trigger the scheduler, it will go ahead and show us running just the one that just for 9/7 because it depends on CLV features MPP. All right. All right, let's continue and take a look at the next step. So the main question that we want to find out is, do we really want to use this feature in our actual prediction? Sorry, for in production. All right, so let's take a look at um, the the dataset classes or the dataset that correspond to the model metrics to see if this actually made an improvement. We'll get this when actually this this model creation runs completely. So we'll wait a few seconds for it to finish. Okay, so this job ran through. So let's go back and refresh our model metrics. So what we see here is that we have an unexpected result, which is that this actually there's no change in data quality or model performance. So I think I know what happened. Again, made a mistake in the job registration, and I did not use the right notebook for this job. I'll go ahead and put this over here. Okay, go ahead and update. All right, and we'll go to this task and repeat this task once more. Okay, and let's wait a little bit until this finishes. Okay, so this rerun has completed. So we should be seeing version 2 here for this one. And now what we see is that because of the rerun, it's using the new set of columns, the 5 column instead of 4, and that has led to an increase in R2. And now we, in fact, that was one of the missing pieces for the data validation. So now model metrics is getting a green check, and our model is actually pretty good. So now we want to migrate this code, this new notebooks to production. And the way we would do this is we'll go to each job and go ahead and change the notebook IDs in it to the new one. So for the production version, so if we modify, put that there, we can make a note. So to be very clear, this is the mechanism that you would use if you were working with notebooks. And working with notebooks is a little awkward. Typically, no one would use notebooks for production. So we are doing our best to use this in production. And so if it seems a little awkward, it's because of the fact that these are notebooks. If you were using Git committed code, this would be much smoother. To be clear, the mechanism is that you would commit your branch code, or this clv features mpv would be running on from a branch, git branch, let's say, and then we'll be writing to this label. And when we are finished with it, we'll be making a pull request, getting it approved by a supervisor who would verify everything. And then when the pull request goes through, automatically all the production jobs will be updated with the new code that is coming from the branch. But since we are working with notebooks, we have to manually change every job that we want to migrate one by one. But as a step, it is good to make these changes one by one to make sure that unwanted changes do not happen. Okay, you're going to update that. You're going to go back here for clv.model, details, modify registration. Going to use that, update. And we have also prepared a notebook for predictions. We're going to um, change that as well, because prediction also requires is needed to use a new column for making the prediction. In addition, we need to actually, so we can also see our schema migration logic. So clv features job and clv model job requires a schema migration schedule. So let's take a look at that as well. So we go back here, clv features, we will modify it. And what we will say is that this dataset can have a different version based on the schedule timestamp. So if you're going to run until 9.7, it's version 1. Because we are really not going to rerun 9.7. So officially, we want version 2 of clv features to be in production from 9.8. So until 9.7, it is 1. From 9.8 is going to be 2. So this schedule that is being provided to Trel registration, to Trel through the registration, is actually going to be responsible for migrating your data from one schema to another schema. Okay, so we're going to update that. It's going to quickly do the same for the model. Again, model metrics does not get a migration. All right, now we have pushed all the changes to production. We have set up a schema migration schedule, and to make sure that the schema migration happens and everything runs successfully, we're going to add the 9.8 data and we will see all the sensors pick this up um, correctly, and we can see the tasks being triggered for it as well. Oh, I'm going to go ahead and cancel this and disable the automation on CLV features, MPV, and the model. All right. So CLV features for 9.8 completed. CLV model for 9.8 is running. And let's take a look at some of the data sets that are getting generated. So we have 9.8, new customer is version 2, transaction history is version 2, CLV features is version 2, um, the schema version 2. And whenever the model creation is done, we can see what that produces as well. Okay, so this has completed as well. And when we go ahead and refresh this, what we see is, yeah, we have model metrics and model, and the model is version 2 as well, supporting the new R2 score in production rather than in the branch, right? So cool. So let's go back to the slides and take a look at um, some of the other aspects of experiment tracking and reproducibility that is covered by Trel. So far, what we have seen is versioning of the overall feature store and schema versioning of the schema and validation rules is possible with Trel. You can construct, experiment, which is doing A/B testing of certain parameters or logics. We can have a reproducible experiment with very high fidelity because of immutable data practices. Um, uh, Multiple times we have seen how the notebooks can be executed in automated manner, and each run we can see what is the input, what is the output, and what was the outcome of it. Now, when it comes to sharing of exact dataset states, this is something we will see a little more detail in a later slide. But if you want to share, suppose the validation, sorry, the model metrics that we were produced to prove to them that hey, our data is being generated correctly, you can simply click this and then share this link with your data team, and they would be able to see the same, and they would be able to click the origin task to see what is the job that actually produced this data set. And we didn't see the version control systems, but I explained how experiment code can be versioned better if we were using version control systems rather than notebook. But we can also see that notebooks are practical solution for building, experimenting, and deploying. We are working on more integration with external model tracking tools such as MLflow and SageMaker, where your models can be pushed to those technologies, and you can further track what is happening with your model in them. So some of the functionalities that is not covered within Trel is versioning of individual features versus the feature store as a whole. Another one is the automated hyperparameter optimization tracking, though we can track the final parameters. Uh, Having said that, um, a form of hyperparameter optimization is possible in Trel, just not the kind of hyperparameter tuning that you would see when you're using scikit-learn and you call a function to sweep through a bunch of parameters. That wouldn't be tracked through Trel, but you can do a for through Trel, and we will actually take a look at this in the next video. All right, we'll see you there.